Hi guys, Mr. Kane here. How you doing?
Hi guys, Mrs. Goswish. We got the band back together.
Hey Mrs. G, is this our last video?
This is the last video for the semester, yeah.
Oh, I was going to say for this year.
Oh, same diff.
Yeah, okay. Alright, so we're going to talk about strong electrolytes and weak electrolytes today. Might as well get the ball rolling, right?
Okay, let's have at it.
Alright, strong electrolytes are salts that dissociate 100% into ions when they're placed in solution.
Okay, so this is just a physical thing we're talking about right now.
Yeah, it's just a physical thing. It means when a salt is placed into a water, it's going to turn into ions. And a strong electrolyte is one that's going to turn into 100% ions.
Okay.
This is different than dissolving.
Okay, yeah, dissolving and dissociation are two different things. Everything can really technically dissolve to some extent. Salts, Mr. Kane, that's all ionic compounds, correct?
Yeah, matter of fact, we're going to be able to look at that solubility rules, because those are all salts.
Okay, yep.
And by looking at the solubility rules, we are going to be able to tell what salts are strong electrolytes and which ones are weak electrolytes.
So a strong electrolyte is one that dissociates 100%.
Kind of like potassium iodide here. Potassium iodide, when you place it in water, completely dissociates into potassium ions and iodide ions.
Okay, so potassium iodide is a solid. All salts are solid at room temperature. And we're making an aqueous solution of potassium iodide. And when we throw the solid potassium iodide into the water, it will dissociate 100% into its potassium and iodide ions, just like you said.
Right.
There'll be no potassium iodide solid in it at all, correct?
Correct.
Just the ions, yeah?
When you toss a reasonable amount in, there won't be any solid.
Yeah, within reason, of course. Everything can be
Yeah, you could
oversaturated.
You could have 4 mils of water and throw 20 mils of
yeah.
potassium iodide in. You're gonna have solid.
Well, let's see now. According to solubility rules, if I read the solubility rules correctly,
It's soluble.
yep, it's soluble.
Potassium is a group 1A element.
Oh, that's right.
So it is definitely soluble.
So if it's a soluble salt, it's going to be a strong electrolyte. If it's a strong electrolyte, it's a soluble salt.
Correct. Now, weak electrolytes, you can kind of infer that they will not dissociate 100% into ions in solution. So when you take lead iodide, for instance, and put it in water, it doesn't dissociate into the lead and the iodide ion. It stays solid as lead iodide.
Okay, so it doesn't dissociate 100%, but it dissociates just a bit.
It might dissociate just a bit, but it's not going to dissociate 100%. That's the key there. Is the 100% is the key to this definition.
Okay.
Okay, and again, that's when you put reasonable amounts of the salt in. So we call lead iodide a weak electrolyte.
And according to solubility rules, it is insoluble.
Right, and those two things go hand in hand. Anything that's insoluble is a weak electrolyte.
Okay.
Anything that's soluble is a strong electrolyte.
Ooh, a movie.
A movie, yep. This is one where you can move things. Check this out. Sodium chloride.
Okay.
It's a salt shaker.
Sodium chloride in water. Sodium chloride is a soluble salt, so it should be a strong electrolyte, and it should dissociate 100% into the sodium ions and the chloride ions, and it does.
And notice it did. When we shook it under the water, it disassociated. Matter of fact, if I could show this, we can pause it and we can show that sodium chloride makes a very nice crystalline structure. Sodium and chlorine, sodium and chlorine, sodium and chlorine, sodium and chlorine, sodium and chlorine. They're all bonded to each other. How's
okay, all right. As a solid, they're bonded in a crystalline structure. That's a solid coming out of that salt shaker. Got it.
And when that solid hits the water, because sodium chloride is soluble, it dissolves completely. It disassociates completely.
Okay, into the sodium ions and the chloride ions. And if you look carefully in the water, you will not see sodium chloride. You will only see sodium ions and chloride ions.
I bet I could make some sodium chloride in the water.
Okay, let's see.
I have to put an unreasonable amount of salt in there.
Let's see. Not yet.
Oh man, I thought that was going to do it. Here, maybe more would be unreasonable. It's floating to the bottom. Yep, there we go. Sinking to the bottom, not floating. Yep, there's a chunk down there.
Sodium chloride down there.
Yep.
Ooh, it's getting eaten away, Mr. King.
Just a little bit, yeah. It kind of
then it reforms.
it's dynamic. It seems to form and reform and form and reform. I can make something resembling lead iodide here. That's a +2 charge in lead iodide. So here we go. We'll try this out.
All right, so lead iodide. Yep.
I don't think that it disassociated 100%.
Nope, did not.
Yeah. I mean, it disassociated a little bit. Look at those. A couple of ions are floating around.
Yeah, but not much.
But it's
not
definitely
like the sodium chloride.
Yeah, that's not 100%.
No way. So it stays. It will not dissociate. Wow.
That's pretty simple, huh?
Yeah.